Our Earth, in its luminous bubble of air. Under this protective layer, life has grown and thrived. Over the last 10,000 years, this unusually stable climate system has allowed for the rise of human civilization, until now. With over 7 billion people consuming the world's resources, economic viability is now pitted against the environment, with little concern for the next generation. People are starting to feel the effects of poor harvests, mega droughts, and extreme floods.
We're all residents of spaceship Earth. Anything we do individually is going to affect everybody else. The cost of saving the planet is something that you really cannot calculate. Because, really speaking, the cost of blowing up the planet would be gigantic.
In 1988, worried scientists established the Intergovernmental Panel on Climate Change to monitor Earth's changes. From the rapid retreat of the Himalayan glaciers, thawing of Arctic permafrost, to ocean acidification, rising CO2 levels threaten our very survival. Scientists across the planet are gathering to ring the warning bell.
Climate change is happening. Scientists are documenting the evidence.
Our model predictions are that by 2100, there will be another 60 centimeters of sea level rise.
It's affecting every aspect of human life on Earth.
We will feel it across the planet.
Are we in the middle of the most crucial moment of Earth's history? How do we attempt to decode this complex climate science? Does preserving our human habitat require a massive paradigm shift? The consequence of our warming atmosphere is impacting the major water towers on the planet. Thousands of research hours have highlighted potential water security, floods, droughts, all symptoms of a changing climate system that requires our greater understanding. Every living thing on the planet requires fresh water. The majestic mountains of the Himalayas provide water for over 1 billion people across India and China. But it is the drama playing out across the major ice fields, the rapid melt of the Greenland ice sheet, Antarctica, the Arctic, and the Himalayas that has scientists most concerned. Here in the high Himalayas, scientists like Jeff Cargill are working at the edge of the melt line to determine the speed of change being monitored and the impacts this will have on neighboring countries and their peoples.
The way I came to be the head of the Global Land Ice Measurements from Space, which is an organization to monitor all the world's glaciers using satellite imaging, with a network of about 180 researchers in at least 30 countries. The way I came to this was actually through Mars. I became very interested in Martian glaciers and Martian ice, and I had to educate myself on ice on Earth.
The dynamic balance of fresh water is being monitored by satellite systems above the Earth and ground surveillance networks across Arctic glacier systems. All data confirms very rapid change has been occurring at the climate front line over the last 10 years.
Think of it as a bank account. If you have a large bank account Initially, you can start to withdraw funds at a very rapid rate, at a rapid pace to support an extravagant lifestyle. And this can last for a while. But then the bank account starts to run dry and it impacts your lifestyle. This is what's happening to the Himalaya now.
Scientists are concerned that unless we dramatically change our carbon footprint now, up to 50% of humanity may be living with severe freshwater shortages within the next quarter century.
People and communities who are underprivileged, who are poor, who really don't have the means to be able to adapt effectively to the impacts of climate change, will be the worst affected. They are the most vulnerable sections of human society.
The annual freshwater melt carried by the Ganges River in India feeds both an agricultural and a cultural way of life for over 400 million people. For Dr. Pachauri, the head of the IPCC, the water shortage is both of local and global concern.
In India, of course, the risks associated with scarcity of water and the stresses that we see with water are very real. In fact, even today, in the state of Maharashtra, which is one of the more prosperous states in the country, there are something like 4,000 to 5,000 tankers of water being moved to a particular area which is drought prone, just to provide people enough water to drink.
Higher temperatures in the oceans load the atmosphere with more vapor. Worldwide, we are experiencing rising numbers of heavy local rainfall that can devastate entire regions.
From a people's perspective, from somebody that has to deal with climate change on the ground, one way to encapsulate it is too much water, too little water, right? So people in villages at certain times will get floods, right? Huge floods coming down to way too much water, and at other times they get too little water and have difficulty with household water or water for their crops. And one of the big challenges from a development perspective is how do we work with communities to solve that big question, too much, too little water.
A joint effort by scientists to produce the most critical report of our time, 30,000 pages of defining climate science. It reads like a top-selling blockbuster, but how do we decode it?
A team with over 300 authors that have worked diligently over a gigantic series of activities. Being involved with my co-chair and the leadership of this scientific team has been one of the great privileges of my scientific career.
This report will now enhance our understanding of issues related to impacts, vulnerability, and adaptation in the field of climate change.
Here, climate drivers, risks, impacts, adaptation, and timeframes are well set out for consideration and action. Regions across the Earth are rated for their vulnerability to climate change. This is possibly the most critical report of our century. But do we really understand what's at stake? Tropical rainforests face an unknown future as this new report puts the web of life under the microscope. Just how fast can tropical ecosystems change? Can they survive a 2 to 4 degree increase this century? One of the most biologically diverse areas on the planet is the Amazon rainforest, located in the tropics. Over 2 million square miles of rainforests, brimming with the most diverse ecosystems on the planet. Its health is important to the whole world. This giant forest stores vast quantities of carbon dioxide. But as mega droughts and floods take hold, trillions of trees could be lost, reducing the rainforest's ability to soak up our excessive CO2. The fate of the Amazon rainforest and its rich biodiversity swings in the balance.
I'm a climate modeler, one of these crazy people that tries to predict how the climate will change over the next 100 years. When I started out on this, I was given the task of putting forests into climate models, which I thought would be interesting. But it was more interesting, it was scary actually, because when we first put forests into climate models, our models predicted that the Amazon forest could die in the 21st century because of climate change. The Amazon's a good case of where the Earth system really plays out. So the things we see here, and the carbon fluxes, the carbon dioxide concentrations we see globally are controlled to a large extent by this forest. And this forest itself is influenced by the ocean temperature, and the ocean temperature influenced by things like carbon dioxide that we put into the atmosphere and other pollutants. So there is a strong connection, and our influence on this forest is both direct through things like deforestation and indirect through climate change.
All living things in tropical forests interact to build the web of life. But what if the web of life is pulled apart? How will this change the Earth's ecosystems? How many species do we stand to lose forever?
It is quite a gamble. We're potentially interfering with the survivability of over half, 2/3 of the types of species on the planet. And it's an unknown. We may find many are resilient, but there's almost certainly amongst those millions of species of the tropics, there are many that cannot cope with the sudden warming of several degrees.
The climate system is highly connected. What happens to the planet affects the Amazon, and what happens to the Amazon affects weather patterns throughout the world. So if the Amazon forest passes a tipping point, we will feel it across the planet.
Tropical rainforests are a major component of our climate system. They are located in warm climate zones where they experience small temperature changes until now. Their fate, like ours, is intertwined in our economic environmental balance.
Rainforests in general serve many functions. They're an important source of biodiversity. They're also an important source of moisture, and that's really my area of interest. Rainforests produce moisture that goes into the atmosphere and affects the regional climate.
Rainforests from the Amazon to the Congo, the Daintree in Australia, to the hinterlands of Malaysia, all play a significant role in the web of life. But change is occurring faster than predicted models. What does this mean for the diversity of life on this planet, not just on land, but below the sea? Below the water's edge, brimming with life, is the Coral Triangle, the underwater equivalent of the Amazon.
Where evolution goes rampant and causes the production of all these species and all this diversity, and it comes out from this coral reef out to the rest of the Indo-Pacific.
Measuring warming ocean temperatures and CO2 acidification levels is vital to predict the rate of change in the coral reefs this century.
What is happening now, which has never happened before, is the change that we're undergoing is so rapid that life cannot adapt to it. In the past, it's been able to adapt to a point, and when that point happens, it's a mass extinction. Life gives up. When a reef is healthy, it is vibrant colour and crawling with life. When it is really suffering, you don't see life everywhere. You see a very much reduced amount of life, and usually very few big fish. If we increase the temperature of the ocean 2 degrees, that pushes coral reefs beyond the limit they're able to tolerate.
It's not just the higher temperatures that hurt the reefs. More carbon dioxide is being absorbed into the ocean, making it more acidic. That makes it hard for coral polyps to generate new coral skeletons, and for reefs and their ecosystems to stay alive.
If coral reefs go, there will be a domino effect onto so many other ecosystems that we have.
We can find lots of reasons why it's important in terms of regulating the climate system, but ultimately I think all of those reasons are a bit utilitarian, and my feeling of why biodiversity is important is that the other 2/3 of species on the planet that live in the tropics have a right to exist as much as we do, and simply we need to leave enough space for our fellow citizens of the planet Earth.
Substantial changes in the structure and function of rainforest, marine, and aquatic ecosystems are under imminent threat this century, as the climate system reaches critical tipping points where changes become irreversible.
Enough is enough. We've reached the ceiling of how much we can transform. Now we need to be stewards of the remaining wetlands, rainforests, grasslands, savannas, natural steppe areas, and keep those intact. That would be a very clever strategy for our own well-being.
Measurements show that key masses in the oceans are changing. As carbon dioxide and heat rise in the atmosphere, so do their levels in the oceans. They absorb vast amounts of the sun's energy, and the ocean currents move this warmth around. They also absorb carbon dioxide, and lots of it. Scientists around the world are working to gather data to help build a picture on the changing health of our oceans. It's a race against time in the deepest, coldest sea, the Great Southern Ocean around Antarctica, where scientists are seeing disturbing changes.
Ocean affects climate by storing and transporting huge amounts of heat and carbon dioxide. And so if we want to understand how climate's going to evolve in the future, we need to know what's happening in the oceans. About 90% of the extra heat energy that's been stored by the Earth system over the last 50 years is in the ocean. So when we talk about global warming, we're really talking about ocean warming in a real sense.
The global ocean system is the largest carbon storage area on the planet. More carbon dioxide is locked away at the bottom of the oceans than in the atmosphere.
3.1 on bottle 5. There's some properties of the ocean, like the temperature, the salinity, and the oxygen levels, we can measure as we lower this instrument from the surface down to the seafloor.
Scientists are beginning to see changes in these carbon locker rooms, especially in deep waters of the Great Southern Ocean.
We can measure those slopes of the sea surface really precisely with satellite measurements now. And that combination of satellites looking down from above and Argo floats profiling from below is really transformed how we do our work in the last 5 or 7 years.
Scientists are measuring rates of change in the deep ocean that are much larger than predicted models. It's a red flag that the system is getting perturbed in a way that might affect its ability to carry our excessive carbon dioxide and slow down the rate of climate change.
Once we remove or thin the floating ice around the edge of Antarctica, more of the ice on the continent tends to spread into the sea. And that transfer of ice from the continent into the ocean does increase sea level rise. And our short satellite measurements over the last 10 years show that both Antarctica and Greenland are making larger and larger contributions to sea level rise as a result of melting around the edges.
The Arctic region is recording temperatures increasing up to 8 times faster than any other region on the planet. The climate system here is becoming more unpredictable. For the animals of the Arctic Kingdom, their world is rapidly melting away. While halfway across the world, scientists are concerned about sea level rise this century that threatens the future of small island communities in the South Pacific. The people of Tuvalu have been recognized as the first climate change refugees due to rising sea levels. Professor Eric van Sebel is studying the effects climate change is having on these islands across the South Pacific.
We've got what we call fingerprints. There's 10 or 15 fingerprints of climate change. And we know from our theories of what global warming would do, we can say what these fingerprints are. For instance, we could say if the world is warming, we expect sea level rise. And we have 15 or so of these, and each and every single one of them is in the direction that we expect due to climate change. Here on Tuvalu, sea level rise in the last 20 years has been 10 centimeters. That's quite a large amount. That's 4 inches of sea level rise in only 20 years. And we expect, our model predictions are, that by 2100 there will be another 60 centimeters of sea level rise here.
In Tuvalu, you can literally experience climate change firsthand. With every king tide, a further habitat is lost. Houses, local crops, freshwater tables are all affected. Globally, more than half of the world's population now live along coastal zones. Sea level rise is a real threat for millions of people, like here on Tuvalu.
Here in Tuvalu is a very good example of this huge adaptation to climate change, because there's really nowhere else to go. They're surrounded by the ocean and they have only one type of location that they can live on. They can't move inland, because once you move inland, you're already in the other ocean.
In such areas, sea level rise has the potential to turn communities upside down from extreme flooding, a result of king tides, storm surges, and wilder weather. Local crops are being destroyed by saltwater inundation, while local fishermen are finding their nets half empty. The inhabitants of Tuvalu already rely on food imports to survive. Millions of people across the world may have to abandon their homelands this century.
The people here in Tuvalu, although they already experience sea level rise, they are, a lot more is coming ahead for them.
The rate of change occurring now is up to 10 times greater than ever before. The fastest the planet has ever heated up has been 4 degrees over 5,000 years, but we are now on target to achieve this in just 100 years. But will the Earth systems and animal kingdoms adapt in this short time frame? Or will some disappear forever? NASA has created a global map of the world's surface temperatures dating back to the 1890s. Over the last 30 years, the Arctic region has warmed up more than 10 times faster than any other region on Earth. A mounting issue causing scientists concern in the Arctic is the rate frozen soil, called permafrost, is thawing. It has carbon inside it, and lots of it, across Alaska and Siberia. Now scientists are scrambling to figure out how much of it could ooze into the atmosphere this century.
Permafrost is essentially frozen dirt. Now, if you took some dirt from your backyard, put some water in it, stuck it in your freezer, that's pretty much what permafrost would look like. Permafrost right here. This is frozen. This will start thawing out very quickly. I can tell right off this is peaty. There's a lot of roots in here. When the permafrost thaws, the organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. Now, if there's no oxygen, the microorganisms make methane. If there's oxygen, the microorganisms make carbon dioxide. It's important to know how much the carbon comes out as methane versus carbon dioxide, because methane is a much more effective greenhouse gas.
Measurements deep into the tundra show that the frozen soil is thawing much faster than predicted models, releasing carbon dioxide into the atmosphere at alarming rates. Scientists are working to identify the potential impact a release of CO2 from these giant reserves could have on the climate systems this century.
Now everybody understands that Arctic is a very important component of the total system, and there should be special attention even to this system because it's so vulnerable and it's changing so rapidly. So my message will be just know more about Earth's system, including permafrost, and pay attention to the Arctic and Antarctic, because that's where changes are happening most rapidly.
In the high Arctic, scientists are monitoring and collecting thawing permafrost samples.
So as the climate changes, we have a choice. We can prevent that change by limiting fossil fuel emissions. We can adapt to that change with technological or expensive adaptations, or we'll suffer for areas that we can't prevent or adapt. And recent studies show that 2/3 of the carbon release from the permafrost region can be avoided if we can limit fossil fuel emissions. So that tells me that it's not too late, that we still can make a difference, even though this is a huge system that will have a large response as the climate changes. It's not too late to avoid a lot of those negative changes.
How long it takes to get up to the top of my wellies. Here we are, down in the fields now, and it's pretty darn wet. Look at that. Don't fancy trying to open that gate.
The Working Group 2 and Working Group 3 reports of the IPCC show a very high risk of huge costs for society if we continue business as usual in terms of emissions of greenhouse gases. And the challenge is to make the transition fast enough, because we're in an urgency situation. We need to start bending the global emissions curve over the next 5, 6, 7 years to have a reasonable chance of avoiding disastrous climate change. And the only way to do that is that all nations in the world need to collaborate.
Over the next 20 years, a growing population will demand a doubling of food production levels. How will changing climate affect the growth and distribution of food to feed a hungry planet? Rising temperatures and increasingly extreme and erratic weather patterns are making it harder to grow enough food to eat. But as droughts and flooding become more frequent, the road ahead for subsistent farmers requires the greatest attention from world leaders. Food security stands to be one of the most critical issues this century from climate change. Concerned farmers in India discuss their crop yields already down by 18% due to rising temperatures.
Sagar, how much has the temperature gone up? By average temperature, how much has it risen?
I think 2 or 3 degrees more.
Say in February, generally the temperature will be around 28, 26. And this time you can see it around 32, 36, 38. We have to concentrate on early maturing varieties, which can escape the heat.
He's saying that he's very worried with the change in the climate. He's worried because the temperatures have gone up. And according to him, there has been an average rise of 2 degrees centigrade in temperature, and that is impacting on the agriculture yields.
The big disparity between night and day temperatures is interfering with the germination of seeds and the health of the plants as they grow.
One of the other interesting facts that was brought about by the farmers here is this information about the world-famous basmati rice. And what the farmers here are saying, because of the rise in temperature, the aroma of that rice has completely gone.
Some of the world's major food crops are very sensitive to high temperatures. Even a single day at 40 C can decrease the yield of a maize crop by as much as 7 to 10%.
Farming techniques that conserve water and soil, especially in dry or desert areas, requires immediate attention as agriculture meets new challenges from a changing climate system.
And they tend to have this threshold sensitivity that we hadn't seen before. Threshold sensitivity means it gets warmer and the yields go up, warmer, they go up a little more, then you hit some temperature and they drop down suddenly. And it's clear that many of the world's major crops, corn, or maize, soy, cotton, all exhibit this threshold behavior. And so a lot of times where we've thought, well, maybe agriculture is okay, it's much more vulnerable than we had realized.
Growing instability in the climate system poses an enormous threat to farming communities and global food stocks.
You have a lot of precipitation coming down in a very short duration of time, followed by drought and then again heavy precipitation. And that is very bad for the crops, for productivity, for yields. And both the changes in the precipitation pattern and the rise in temperature, the farmers are struggling.
From now on, all nations across the planet have a big food security problem due to committed greenhouse gases locked into global warming.
पानी आ गया बहुत सारा ये क्या है
Climate change has already begun to hold back wheat, rice, maize, and soy yields. Greater reductions in food availability may lead to price swings that could in turn lead to civil unrest in countries that are already having problems meeting the basic dietary needs of their citizens. Adaptation and mitigation will be vital to ensure abundance of produce for all peoples of planet Earth this century. Climate change poses a growing threat to human health worldwide, as extreme weather and rising temperatures provide a new vehicle for diseases to spread across the globe. Climate change is no longer only an environmental issue. It is a health issue, and a rapidly growing one. But who is most at risk?
The heat wave of 2003 in Central Europe killed somewhere between 10,000 and maybe 50,000 people. And the people who died in that heat wave were the elderly, the people who were already sick. In some cases, it was the very young. And so what tends to happen is that the biggest health impacts of climate change fall unfairly on those who already have poor health.
So when there is not enough rainfall, it means that people do not have enough fresh or clean water to bathe in or cook with or wash their hands with. So you have people preparing food with unclean hands. You have mothers preparing food for babies with unclean hands. And then when there's too much rain, then you see what happens is that there are a lot of contaminants being brought into water supply systems by the rain or by floods, for example. And then when people consume this contaminated water, then diarrhea can increase again. I think it will become a very big challenge to eradicate or even manage diseases at that time, because 4 or 5 degrees increase in temperature is not just what you experience as heat. It will also change our rainfall patterns. It will also change the levels of sea level rise. And then there will be, flow-on effects onto agriculture, health. So these are the various determinants of health.
Whoa, block out the sun. Here we come. Wow.
The spread of pests, diseases, or epidemics are observed worldwide by a network of specialized institutes. Here also, deadly viruses like Ebola can be safely examined. A warmer climate favors the spread of otherwise locally occurring tropical diseases and provides new transport methods from animals to sandstorms to megastorms.
Arboviruses are viruses that are transmitted by arthropods, for example, mosquitoes or ticks. So this is our main focus in the research. And the most important arbovirus worldwide is the dengue virus, which causes around 400 million infections every year.
Because you have a forest here.
A researcher from the Central African state of Benin has brought virus-carrying mosquitoes to the lab. Here in Germany, he is breeding them using human blood in order to investigate the pathways of such viruses through mosquitoes. This includes such diseases as dengue fever, Ebola, and others, as climate change breeds new environments for deadly outbreaks.
Back home, I think I will train other people on this technology, how to detect dengue fever. And this is very important for us because people will be trained in the south, in the northern Benin. So in case we'll have a kind of this disease, quickly we can work on it to avoid many people to die from this dengue fever.
In Germany, Dr. Schmidt-Schanazit goes hunting for virus-carrying mosquitoes.
Temperature is a very important factor for the emergence of viruses that can trigger some outbreaks that are caused by these mosquito-borne viruses. We have different trapping sites all over Germany, like 20 or 25, and we are going there to trap mosquitoes all over the year. The mosquitoes were trapped and analyzed for these viruses, and if we detect those viruses, it is an early warning system, and we communicate our results with the public health offices and agency and the hospitals and say, please be alerted, there might be new viruses in your area that may cause human disease.
Research in search for viruses is extremely costly work for specialists. Poorer countries have to rely on the international cooperation of the science community.
Now we have a large outbreak in South and Central America of the chikungunya virus, which will affect millions of people and cause severe damage to the public health system, because this virus will affect the joints and cause joint pains for months, so they cannot work, and this will cause a severe damage also to the economy. Information is the key. This is what we are doing in Brazil. We try to train children in the favelas to explain their parents and their friends what are ideal breeding grounds for mosquitoes, so that they can remove these breeding grounds. And if there are no breeding ground, the mosquito cannot survive, and the risk to catch up dengue will be lower.
The question of how we produce energy marks the beginning and the end of all climate change. The accelerated use of fossil fuels like coal, oil, and gas has triggered the destabilization of our climate system. Fossil fuels are replaceable, but will we make the transition to non-destructive energy solutions in time? Today, we burn fossil matter to extract the energy of millions of solar years per year. The result is the release of huge quantities of greenhouse gases, like carbon dioxide, that once have been safely stored away. Environmental scientists like Dr. Alan Robach have long known and described the consequences of this cheap energy production.
It's clear that humans are the greatest cause of climate change right now, and if we continue in our current behavior, the planet's going to warm at the fastest rate ever before experienced by our species, to a level never before experienced by our species. And the only thing we can do is to stop putting carbon dioxide in the atmosphere, stop using the atmosphere as a sewer. We can do it, the technology exists. We can use wind and we can use solar, we can use energy more efficiently. And we have to start now if we want to avoid really dangerous climate change in the future.
Near Cologne, in Germany, the company Rheinbraun operates huge excavators busily digging the largest man-made hole in the world. They extract brown coal to burn for electricity. 40 years ago, this was still fertile farmland. Today, the hole is already 11 kilometers long, 5 kilometers wide, and 500 meters deep.
The first and most urgent industry that needs to die is the coal industry. So we need to pull out of coal, totally pull out of coal, which is very, very difficult in countries particularly like China and even in countries like Australia, depending to a very large extent on coal. The way to transition out of coal is through a price on carbon. If you price coal right, coal is no longer attractive as an energy source.
The fossil fuel industry has been one of the main drivers of climate change. The IPCC reports suggest a transition to cleaner energy solutions in the next 30 years. This could create a huge innovation boost both for industry and society.
When you put very tough regulations on environment, it actually stimulates technological breakthroughs, which ultimately leads to both sustainability and cheaper consumer goods for us, human beings.
Only a few years ago, the rapid development of renewable energy from wind and sun had hardly been imagined. Today, more than a quarter of electricity for an industrial nation like Germany is already produced this way, with the goal to reach 70% in a couple of decades. No user will notice the difference. The electricity is just the same.
Personally, I see climate change as one of the great opportunities of the 21st century. I mean, we're talking about a whole new generation of companies, a whole new generation of technologies, and a whole new generation of opportunities to make those things realities. I mean, if I were starting my career right now, I would be thinking the greatest opportunities are going to be in providing the energy services of the middle of the 21st century.
Renewable energy research enjoys growing popularity among students and university graduates. In these academic working groups, they look for new ways to use energy more efficiently. The intelligent use of information networks will play an important role in the future of energy production and consumption. This will eventually lead to downsized and decentralized energy solutions available to everyone. Now scientists and politicians are speaking about the cost of action versus inaction. The latest IPCC reports clearly state the sooner we act, the less costly it will be for the world's economies. Can we afford to wait? Can we afford to hope climate change will go away? For more and more regions, rising temperatures are a bitter reality. In Africa, in India, or the Middle East, people, animals, and plants can barely cope with growing heat. At the same time, the knowledge about the functioning of the Earth's climate system is growing fast. Scientists are collaborating and sharing their findings. Could they become a role model of how crisis management could work? A symbol of global cooperation and exchange of best practices for the better of all?
What we've seen over the last century is a temperature increase of about 1 degree Celsius globally. Now, what is natural for the planet? When the planet moves from an ice age into a warmer phase, then temperature tends to increase globally at a rate of about 1 degree Celsius every 1,000 years, or perhaps 2,000 years. So what we are looking at here is an increase in the global temperature that is taking place at a rate that is about 10 times faster than any natural process.
Our Earth, in its luminous bubble of air, our atmosphere has enabled the successful expansion of intelligent civilizations around the planet. Now our survival will depend on how we best make use of this intelligence to mitigate climate change over the next 20 years and manage to adapt to its inevitable consequences.
And some people would say, well, that means there's no reason to act. But that's a strange thing to say. It's a bit like saying, I know there's a staircase coming and I'm in the dark, so I'm going to carry on going at full speed. You'd never do that. So I think the thing about tipping points is that we don't have to know exactly where they are. We might never know until we've crossed one. But the existence of them is a bit like running towards a staircase in the dark. It makes sense to slow down, it makes sense to get a torch, and it makes sense to stop before you tumble down the staircase.
The 21st century really is going to be a time when we need to use science and technology to work with the planet rather than to work against the planet. And so I think there are tremendous opportunities available as a researcher. I think there are tremendous opportunities available as a scientist. I think there are tremendous opportunities available as an entrepreneur to start the businesses that'll provide the technologies. And I also think there are tremendous opportunities as an activist in order to help society recognize where the problems are and where the opportunities are.
In fact, it's a very exciting time to live on Earth because it is a moment of a great transition. You know, if you look at energy, food, resource use, and you look at the trajectories ahead, you know, the only word that applies is revolution.
Will the winds of change inspire the youth of the world to find new and unexpected solutions?
If students come to me and say, you know, I'm really worried about this, I took your class, what do I do? What I tell them is, do something that you're really excited and interested about, become an expert in it, and then apply your knowledge to an environmental cause. And you could be a scientist, you could be in the social sciences, you could be in the humanities, you could be an artist. Anything you want to do that well, and then do it for a good cause.
Youth have the ability to cross the barriers of political boundaries and distinctions of race, religion, and other factors. And I think if they were to join hands and really start a major effort globally, then it'll sensitize all of humanity.
After the IPCC was founded in 1988, scientists and researchers were surprised that their message was not taken up globally and actioned quickly. Now many hope for the next generation to succeed in responding to these threats more effectively.
My advice to the leaders of India, China, the US, other nations is simply to wake up. The evidence of climate change is right in their faces.
It's a coherent picture. Everything just points in the same direction. There's really no way out of that. There's no escape hatch somewhere that you say, well, but there's one measurement that that can't fit our story.
We have some time to figure things out. We don't have time to waste.
The mitigation train is waiting at the station. It has to take off quickly at very high speed, and the whole world has to be on board.
The message from over 3,000 scientists is clear. The plan for Earth's survival cannot wait a moment longer. It needs people to take the lead to make it happen.